In this chapter, we will be analyzing rational expressions and equations. In this lesson, we will be adding and subtracting rational expressions. And to begin, we're going to limit ourselves to looking at expressions with monomial and binomial denominators.
Alright, hi everybody. So now in this lesson here, we are going to be looking at adding and subtracting rational expressions, okay? And they're going to have monomial and binomial denominators. We'll kind of split them up into the two different groups here and take a look at each one here. Although, really, there's not much difference between how you treat the two of them there. And this is just adding and subtracting fractions. Now, I say that as if it's, oh, that's all it is. However, I know that that's probably one of the more difficult things that you have done in your mathematical background. You throw a rock in the air, you're going to hit somebody who does not like adding and subtracting fractions. That's just the way it works here. So I'm going to talk really quickly about this, then we're going to go through and do some examples, but it's really going to be in the doing of the examples that I think you're going to get a sense of how I want you to approach this. So the first thing we're going to do is we're going to factor. And this is so that we can understand clearly what we're looking at in the denominators. Okay? Because our first goal is, and by this point in time you already know this, but we need to find the lowest common denominator. And the only way we can do that is by factoring those denominators. So what we're looking at here is we're looking at representatives. The lowest common denominator is going to be an expression, okay, that has every factor represented in it. Okay? And it's going to have that factor represented the maximum number of times it shows up in any one denominator. That might not make sense, but I'll refer back to that when we get to it. Then you're going to want to state NPVs. That's important. Not necessarily for what we're about to do here. I mean, it is, but this is going to be more important when we get to solving. And anyway. We're going to, now it says here, write the common denominator on top of each term. Essentially what we're trying to do here is, basically, you're going to find equivalent fractions with the same denominator, okay, in every case here. So that's maybe the best way to write this, is we want equivalent, okay, we want equivalent fractions or equivalent rational expressions with the same denominator, that common denominator. Then we're going to add and subtract the numerators. I have seen over the years that this tends to be a point of confusion. I want to make sure that people are doing this correctly. I really do believe that one of the reasons why people have difficulty with adding and subtracting fractions is because we have gotten lazy in the way that we communicate mathematics. And so we oftentimes say things that we don't actually mean, and we're hoping that our intentions are getting through. Even as teachers, I'm hoping that, like, when I say things slightly incorrectly, I'm still hoping that my idea gets across, and that, I think, is becoming more and more of an issue. We need to be more clear about how we say this. Now, I'm guilty of that too, and I get that. I'm not the best example of that, but I do recognize that as an issue here. So you're going to see, I'm going to try really hard to focus our attention here on places where that kind of pops up, and so hopefully it'll make sense to you and it'll be something that you can use kind of going forward in the future here. And anyway, the last thing we're going to do is check for any further simplifying. What I want you to do though is I want you to leave the denominator, okay, factored. You're going to have to expand out the numerators, group them together, and then try to factor that again so you can simplify. But as soon as we got the lowest common denominator, I just want you to leave it in factored form because that's where it's going to be most useful to you, okay? All right, anyway, let's move on here. Let's just do some examples. Okay, here we go. Now, the question here said solve for x, but that's a misprint here. That really should just say add and subtract the following expressions. There's no solving going on here at all. If there's no equations, there's no solving. Okay, so here we go. Really straightforward sum of two rationals here. Notice that the denominator is the same in both cases here. Now, where people make the mistake when they look at something like this and need to add them together is they look at this as 2 divided by x plus 4 divided by x. That is not incorrect, but it's not useful. Okay, don't think of it like that. you want to change the way you talk about this. The division by x here, if you think about the way you would have learned to have talked about fractions here, this is 2x plus 4x. Now when I teach this, I really overemphasize that. I stick my tongue out while I'm doing that to point out here that when we're adding and subtracting fractions, the numerator tells you quantity. Okay, the numerator is telling you the quantity. The denominator is giving you the size of the object that you're adding and subtracting. So this is really like saying, think of it like this. I might even replace this. I could say here that the letter A is going to be 1 over x. And so what I've got here are 2a's plus 4a's. 2x's plus 4x's is how many x's? Well, there are 6x's. Just like down here, this would be 6a's. Okay? It helps to think of it like that, to speak it through that way, because then I think the adding and the subtracting of fractions simply makes more sense. But if you look at this as simply 2 divided by x plus 4 divided by x, you're going to get lost in the algebra. And ultimately, you're going to get lost in terms of algebra that you see happening but doesn't actually occur here. I'm not actually going to perform the division here, 6 divided by x. I don't know what x is. I can't do it. So I'm not going to worry myself with it. I'm going to worry about the fact that the part of that I can work with, and that's adding together the numerators. Now I do need to state one more thing here. Although it's not absolutely necessary to do this, again, as teachers, I want you to jump through this hoop. I want you to state the non-permissible. In this case, x can't be 0. In this next question, I have got, now I can't, there's nothing to factor here. Everything is as simple as it's going to get. I've got 5x 3y plus 4y 7x. Okay? So what I need here is I need to find a common denominator. I cannot add these together the way they stand here because it's like 5x of something plus 4y of something completely different. I need those to be, the denominators to be the same here. Now, let's think about our common denominator. We're going to put the least common multiple, okay, of our denominator here. Well, this has a factor of 3. This has a factor of y. 7 is a prime, so all on its lonesome here, and then I've got this factor of x there. So altogether, this is going to be 21xy. That is going to be our least common denominator. Now, what I'm interested in here is this is what my denominator is going to be. Okay, I know that. I know this is going to end up being 21xy plus something over 21, can you see, I'll see that? Yeah, xy. Now, what did I have to multiply by the denominator to turn that into 21xy? Because it doesn't matter what I convert it to, as long as I do the same thing to the numerator and the denominator. So I had to multiply this by 7x. Now that means I have to multiply the numerator by 7x. Now bear in mind what I did. If you multiply the the numerator by 7x and the denominator by 7x, those would cancel. That's just like multiplying this whole thing by 1. So technically I haven't done anything. So then this becomes 35, that's 5 times 7, x times x is x squared. Okay, now, and there is some confusion about that I see pop up every once in a while. X times x is going to be x squared. Okay, let's take a quick look at this one over here. In order to get this to 21xy, I had to multiply this one by the 3y. 3y, same argument there, multiplying by 3y over 3y is just like multiplying by 1. And then that's going to give me 12y squared. Okay, good. So now what I've got is I've got 35x squared, 21xy, and I'm going to add 12y squared, 21xy. So altogether, how many 21xy do I have? Well, I would have to add the numerators together. Now, because they're unlike terms, the best I can do is simply state that they need to be added together. I don't know what it is. I don't know what the sum is supposed to be until I know what the values of x and y are. This is as far as I can go. All I know is that I would have to add those two things together. So anyway, that's where I end here. I look at my non-permissible values. I know that x cannot be equal to 0, and I can see that y cannot equal 0. Now, I haven't canceled anything. Okay, so those are restrictions that I see at the very end anyway. All right, this one right here. Bear in mind when you got that number all by itself, its denominator is going to be just 1. So the least common multiple of the two denominators, and this is straightforward because since this is 1 here, it's all going to come from the second term. Okay, so 4a. However, I kind of pausing there because I really want people to look at that. What I just did here is a really natural kind of first step for people to take here. And you would not get the answer wrong if you did this, but I just want to pause here. Just take a look at what I've got here in that fraction right there. Hopefully you see it. Okay. If not, there is a little bit of simplifying that can happen here. I've still got 8, and I'll put that as 8 over 1 in just a second if I need it here. 20 divided by 4 is going to give me 5 in the numerator. B, well, there's no factor of b to cancel a denominator, but a divided by a is just going to be 1. So notice that the denominator completely disappeared. So when I was looking for the lowest common multiple of the denominators, that works, and it would have worked, and I would have gotten the correct answer. But I'm taking more time around that problem than I really need to. That one can simplify down, and it simply becomes 8 plus 5b. These are unlike terms, so the best I can do is to tell you that I need to add those two together. That is as simple as it's going to get. I did cancel out the a's here, so in this case I really do need to state that a cannot equal 0. That's a restriction that no longer is apparent in this expression, so it needs to be added because it was a restriction here. So simplify if you can. All right, this one right here. Okay, so now I've got a denominator of x, I've got a denominator of 3x here. You might be very persuaded to cancel those x's there, but remember that bar always puts parentheses around the numerator and denominator. That means that this whole thing is one unit here. I can't cancel the x from just part of it. Okay, I have to treat that as a whole. And because I don't know how x plus 5 specifically is going to relate to x, I mean, it would depend on the value of x, I can't just cancel those out. Same thing here. I cannot cancel those x's out here. Now, the least common multiple of my denominators, well, each one of those is going to have an x in it. Now, I only need to have one representative. I've got an x here, I've got an x here. They are in both. So my least common multiple is going to have an x in it. The only other factor that shows up is that 3. So my least common multiple is going to be 3x. So I know that my denominators here are going to be 3x adding a term with a denominator of 3x. Now that I didn't change anything to that second term, so it's going to stay x plus 2. But here I am missing a factor of 3 in the denominator, so I'm going to have to put a 3 right there. And if I do that, I got to put it in the numerator. That way 3 divided by 3 is just 1. So I haven't changed this term, okay? So I've got this 3 multiplied by x plus 5. Good. There we go. So now I've got 3x plus 5, 3x plus x plus 2, 3x. Now what I've got to do here is I'm going to add those numerators. So that's going to be, now, okay, I'll write it like this. The more comfortable you are with this, the faster you can get through this. So essentially what I've done in that step there is just identify that they are being added together. But now I actually have to do this addition. So I'm going to distribute. This will be 3x plus 15 when that 3 gets distributed to both terms, plus x plus 2 all over 3x. Okay, and so now putting the numerator together, 3x plus x, I have got 4x. 15 plus 2 is 17. So I have got 4x plus 17, 3x. Okay? So remember, the numerator tells you how many you've got. The denominator tells you the size of the objects that you're adding together. In this case here, I didn't really cancel anything out here, but so I'm just going to state the restriction that I see right there, and I see that x can't equal 0. A lot of times I'll have people say, well, wait a second, isn't the restriction that x can't equal 3? Because they see the 3 down there, but if x is 3, you get 3 times 3 is 9. That's totally fine. It's division by 0 that I can't allow. So if x was equal to 0, then 3 times 0 is 0. That's why 0 is the problem. Okay, let's keep going. Over here. Okay, we got more terms here. That 3x kind of shows its face again. Again, you might be tempted to want to cancel those 5's there, but remember, when you've got a binomial like that, that division symbol puts parentheses there, and I have to treat that as a whole group. I can't just cancel the 5 out of a part of it. It would have to be out of the whole thing. And right now, I can't separate that 5 away from that binomial. It's stuck. Okay? And the same thing with these two 3's over here. Okay? If I could remove a 3, like factor a 3 out of that, then yes, I could cancel it. But man, that's all one unit. And so you can't cancel the 3 out of part of it. So now I got to look at my denominators here and figure out what my least common multiple is. Well, this has got a factor of 5 in it, so my least common multiple's got to have a factor of 5 in it. The 1 is just 1 over 1. So I'm not going to state that my least common multiple has to have a 1 as a factor, because that's really trivial. But over here, I see that's got a factor of 3 and a factor of x. So this has got to have a factor of 3 and a factor of x in it, meaning that my least common multiple here, or the common denominator, is going to be 15x. Now I go back, and I'm going to rewrite this expression with that common denominator. Now here, I have to multiply by 3x, numerator and denominator. So I will get 3x multiplied by 5x minus 1. I'll deal with that in just a second. That's going to give me 15x. The 1, and I really hope this is clear, I have to multiply numerator and denominator by that 15x. So that's going to be 15x over 15x. That should be easy. Over here, the factor that's missing is the 5. So it'll be 5 multiplied by 4x. I know I'm going right off the screen here, aren't I? Yeah. 4x minus 3 all over 15x. I'll try to pull this back a little bit here. So now all of my denominators are the same. So this is going to be all over 15x. Now, just to kind of push this along here, instead of just writing those all together, I'm going to start to do that little bit of work that this is implying. I have to multiply that 3x through to both of those terms. So it'll become 15x squared minus 3x. Okay, all I did was distribute the 3x through to both of those terms. That's it. Plus the 15x that's just kind of hanging out all by itself out here. And now I'm going to distribute that negative 5 through. So negative 20x, and be really careful about this, plus 15. It's going to be very tempting for some people to put the wrong sign there, but that negative sits out front here. And essentially, to make that a little easier on myself, I can think of that as negative 5 being distributed through. This is all over 15x. Now I'm going to put together the like terms. 15x squared, there is nothing that is considered like to that. But here I've got negative 3x plus 15x minus 20x. Now just think about that. Negative 3x's here plus 15x's. Well, that's a total of 12x's. Minus 20x's is going to be negative 8x. And then the 15 didn't have anything that I could combine with it. Great! Now, I'm almost done here. Is there any sort of simplifying I could do here? Well, no. Bear in mind, I would be able to cancel that 15 if I could, the 15 was a factor of everything here. If I could factor the 15 out, I could separate it, then I could cancel it out here. But as it sits right now, that 15 and that 15 are locked inside a trinomial. I cannot cancel out pieces of a trinomial. Now, if I distributed this division by 15x to each and every term, and I mean that each and every term, because you can do that, that ended up taking me right back up to the original question. I would have gone a full 180 and gone right back to the beginning. That is as nice as it's going to get. Even if I can manage to be able to factor this, with a trinomial here, I would end up with binomial factors, and the denominator isn't a binomial. There's nothing I would be able to cancel. That's about as good as that's going to get. And even though it's visible at the end here, we want you to do this. State the restriction, x can't be equal to 0. All right, another one here. Okay, now we got a little bit more going on here. And actually, this is going to give us an opportunity to have a little bit more of a discussion about the way the lowest common multiple works here. Notice that the issue here is in my denominator. Okay, that's where most of the math is happening here. So the least common multiple of my denominators, this is how this has to work. First of all, I want to make sure that these are all in factored form. And the reason why we're working with monomial denominators is because they're more obviously in factored form than if we was to have binomials down here. So this is kind of a nice, gentle introduction to this. My least common multiple for the denominators has got to have a 2 as a factor because this has a 2 as a factor. It has got to have an m squared as a factor because this has an m squared. It has to have an n as a factor. Now, I move to the next one. Notice that the next term here has an m squared in the denominator. Well, I've already got that, which is awesome. I don't need anything more with the m's there. Good. I need an n cubed. Well, I had an n. Okay, n's not enough to cover this. An n by itself does not represent that factor. So I'm going to put an n cubed there. Now, bear in mind, having 3 of them means I do in fact have at least that one there. So this right here represents this denominator plus a little bit more, and this denominator plus a little bit more. Now come over here. This denominator has a factor of 5 in it. Okay, there is no factor of 5 here, so I have to introduce a factor of 5. This has a factor of m to the 1. Well, this has got 2 of them, so I'm covered. This has got an n to the 1, and I've got 3. Again, I'm covered. So putting that all together, the least common multiple of the denominator here is going to be 10 m squared n cubed. This has got every single denominator represented in it. It's more than each one of those, but it has at least each one in it. Now, okay, we're going to rewrite this term here. Each one of these is going to have the denominator 10m squared n cubed. That'll be minus 10m squared n cubed plus over 10m squared n cubed. And I know I'm running off the end here. Now here, to turn this one into that denominator, I am missing a factor of 5. So I got to multiply by 5. I've got all the m's there, I'm good with that, but I need to multiply by 2 more n's to balance that out here. So this is going to become 15n squared. In this second term here, I am missing just the factor of 10. So I got to put that in the numerator as well to balance that out. And then over here, I've got this 5mn. Okay, well, I'm missing a factor of 2. I got to multiply that by 2. My denominator has m squared, and I've only got an m, so I have to put another m there. And 2n. So I've got to multiply numerator and denominator by 2mn squared. So it's going to give me 8mn squared in my numerator. So now all of the denominators are identical. We are adding the exact same thing. I'm adding together a bunch of 10m squared n cubed. So 10m squared n cubed. And what have I got? I've got 15n squared of those minus 10 plus 8mn squared. At this point here, I would want to try to put those together. The first thing I might want to do here is try to factor this to see if there's any factors I can cancel. But there is nothing common to all 3 of those terms. There's no factors that are all common. There's a 2 that's common to both of those, but not to the 15. There's a 5 common to both of those, but not to all 3. Like, there's really nothing I can do to factor that. Okay? In fact, the only thing that you might do with this to make it look a little bit better is to put it in this order. This is closer to standard form. Okay, just the way we've set that up there. Now, the last thing that we're going to get you to do here is simply state the restrictions, which aren't any different than they were from the beginning. M can't equal 0 and n can't equal 0. I didn't cancel anything that had n's or m's in it, so those restrictions were the same as they were at the beginning. There we go. All right, so in this question right here, again, looking at all the denominators here, this is actually kind of nice here. Everything is already in factored form, and my denominators are relatively simple, at least a little bit simpler than the last one. In this case, the numerators are a little bit more complicated. The least common multiples of my denominators, well, here, it's got to have a factor of x in it. So let's take a look over here. This one tells me that it's got to have a factor of x. I do. Perfect. It's also got to have a y. Wonderful. Then I come over here. This tells me that my common denominator has to have a factor of y in it. It already does. So I'm covered. That's the least common multiple. Okay, so that's going to be my lowest common denominator, which means this expression right here, and maybe what I'll do is I'll start writing it right here. In order to get that least common denominator, xy, 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 here I am missing a factor of y. Now remember the parentheses. Got to go around the whole denominator so that this gets multiplied through. This was perfect, just the way it was, because the denominator was already equivalent to my lowest common multiple. Perfect. This one right here, I am missing a factor of x, so I got to put that through. So here, this will become xy minus 2y squared. I'm going to put that in parentheses. Minus, I didn't have to do anything to the second one, but I'm going to put that in parentheses as well. And then here, minus 3x squared minus 4y, and again, I'll put that in parentheses. So I'm just distributing those factors through, and the operations stay the same. Now, because they're all over xy, so I'm adding a bunch of xy's, I can put this all over xy, and now I'm going to drop the parentheses. So xy minus 2y squared minus 4x minus y, because I'm going to distribute that negative through, minus 3x squared, and here's where this might cause a few people to stumble a little bit. That negative gets distributed to both terms. That's why that negative 4y becomes a positive 4y. Now, in my very last step here, it's still over xy, but I'm going to group together like terms if I can. Okay, I've got an xy term. Now, normally the way we would write this is we would do this in alphabetical order, in order of decreasing degree. So I'm going to pull that negative 3x squared up front. Then I've got the positive xy minus 2y squared. So I'm getting rid of the x here, then the y's pop up. Then I've got a negative 4x, and then the only combining that I can do is this negative y and this 4y, so this gives me plus 3y here. That is about as good as that's going to get, because other than those two, there are no other like terms. So at this point, I'm basically done except for stating the non-permissibles. I didn't have to cancel at any point, so the non-permissibles I have at the end here are the same as they were at the beginning. X cannot equal 0, y cannot equal 0. That's what we're looking for. All right, now we're going to do questions with binomial denominators. And I'm hoping that as we go through these examples, you're going to see how really there's really not much difference than this and what we were just doing with the monomial denominators. So let's take a look here. So it's important, and I've set this kind of precedence before, it's important that we look at these things and make them look pretty. Okay? So in this case, when I look at this question here, very first thing I notice is that doesn't look pretty. The reason it doesn't look pretty is because the A and the B are out of order. It should be in alphabetical order. Now the nice thing is about addition is it's commutative, so I can flip those around and they remain the same. So my denominator here is A plus B. So I'm adding 11 A plus B's, and from that I'm subtracting, or I'm adding negative 7 A plus B's. So the denominator is the same. 11 minus 7 is going to be 4. So my answer here is going to be 4 A plus B's. Now, I didn't cancel anything from the denominator. I didn't cancel any variables. So what I'm going to be left with, and actually I'll come up here and do it first, I know that A plus B cannot equal 0. And I can kind of manipulate this in a couple of different ways. But I suspect that most of you would do it like this, and we'll simply say that A cannot be equal to negative B. So we'll write that down here. A cannot equal negative B. That's my restriction. All right, here, okay, beautiful. The denominators are already the same. We're already adding the exact same thing. I'm adding x plus fourths. So I can put these all over the same denominator immediately. All I got to remember here is that subtraction is going to distribute to this whole numerator. I am subtracting this whole thing. So this will be 3x minus 2x minus 5. Okay? And now I just put together the like terms. 3x minus 2x is just going to be x. minus 5 over x plus 4. Wonderful. And once again, I never canceled anything. So the restriction that I get at the end is the restriction I had from the beginning. X cannot equal negative 4. You just got to state that. C. Again, the very first thing I see is my eye is drawn to this. It looks weird. So I'm going to put this in the correct order. Now I'm going to go through this one pretty slow. Okay? I really encourage you, the more comfortable you are with this, by all means, just run through it. But for those that are maybe a little bit weaker on what I'm doing here, I'm going to go through this a little bit slower here. I am doing this, I'm making this look pretty, because when you make it look pretty, it turns out the math is easier to do. One of the things that we as teachers do is to make it more difficult for you is we make it look a little ugly. It kind of force you to have to navigate your way around that. Well, don't. Make it look pretty. Fix it. So to start off with, for example, I don't like having the x at the end here. Now, if I'm going to switch the order does matter with subtraction. It does. But I can rethink subtraction as adding a negative, and order doesn't matter with addition. And that's how I'm going to do this. So I'm kind of going to sneak my way around this. So I'm going to make that negative x plus 2, and then minus 2 over x minus 2. Now, I still don't particularly like that. The reason I don't really like it is because I don't like having the negative at the front. Now, sometimes you can't get away from it. Sometimes that's just the way it is. But here, I can. I'm going to factor that negative out. And that's going to leave me with negative bracket x minus 2. It's going to change the signs on both of those terms. Now, one of the things I have the freedom to do is a positive divided by a negative is negative. A negative divided by a positive is negative. I can actually move that negative wherever I want. So I'm going to move that negative up to the numerator. And so now, look what I've got. Okay, I have now got myself in a position where the denominators are exactly the same. I have common denominators. And that wasn't even my goal at this point. My goal was simply to make the question prettier than it was at the beginning. That's all I wanted. And it worked out beautifully for me, because now I've got a common denominator of x minus 2, and I'm just going to put those two expressions together, negative x minus 2. Now I can't cancel anything here, because I can only cancel factors. Factors of the numerator with factors of the denominator. And the truth is, x isn't a factor, neither is 2. Those aren't factors. Factors imply multiplication, and these are being subtracted. So there's really nothing I can do. At the very least, okay, or I should say the very best, I could factor out a common negative out of the numerator, but that's going to get me x plus 2 in the numerator, and the denominator is still x minus 2. So that is about as good as it can get here. I didn't cancel any expressions with x in it, so the restriction that I get at the end here is the restriction I started with, and the restriction here is that x cannot equal positive 2. Okay, now bear in mind, and I know we said this before, but I should say it again here, 0 is not automatically a restriction. I could plug 0 into this, and if you did, 0 minus 2 is negative 2. 0 plus 2 is positive 2 with the negative, becomes negative 2 over negative 2, just becomes 1. 1 is okay. I have no problems with 1. What I have a problem with is division by 0. If the whole thing becomes 0, that's an issue. Let's keep going. Okay, now it's getting a little bit more interesting here. Notice that everything here is factored. Okay, there wasn't much going on here to begin with, but everything here is factored. There's nothing I can factor out. That's as good as it's going to get. But my denominators are different. So when I start to look for the lowest common multiple of my denominators, you gotta hear me out when I do this. I am looking for factors of the denominator. So, and I'm looking for common factors. Please do not tell me that x is a common factor. X is not a common factor in these denominators. When I say the word common here, in most cases, most teachers, again, we're a little bit guilty of being a little bit lazy with the vocabulary. When I ask what's common to the denominators, don't say x. I understand x is in a sense of the word common because, hey, there's an x here, there's an x here. Just like where I live, rabbits are common. There's rabbit there, there's a rabbit there. There's rabbits everywhere. I see them all over the place. That's not what I'm talking about here. When we say that, I'm implying a common factor, which means x is being multiplied by something. But here it's not. It's being added to 3. Because of that, I can't separate the x from the 3. Just like here, I cannot separate the x from the -6. There are parentheses around those. That means this whole thing, that binomial, is a factor of the denominator. This binomial is a factor of the denominator. So my least common multiple here has got to have x plus 3 as a factor, because it's a factor here. It's also got to have x minus 6 as a factor, because it's a factor in that second term. So my least common multiple is going to be the product of those two. Okay, meaning that my expression here, and I'm going to come down to here. Okay, my expression here is going to have x plus 3 in it, x minus 6, and then we're going to subtract. That other fraction will have x plus 3 in it, x minus 6. So because this is my least common multiple here, I got to now look at this here. What factor is missing in my first term? And the answer is the x minus 6, so I'll put that there. And just like we did with the monomial rational expressions, I'm going to have to put that numerator and denominator. In this second term, I'm missing the x plus 3. So again, I put that there. I got to put it in the numerator and denominator. So this becomes, if you will, 3x multiplied by x minus 6. Now granted, I changed the order of that, but because I'm multiplying them, I can do that. That's fine. Make this 4x, x plus 3. Now, I'm going to put these all together over x plus 3, x minus 6. Now notice I'm not going to multiply that denominator out. The reason I don't do that is because if I'm ever going to simplify it, I want it in factored form. It already is in factored form. I don't want to mess with that. In my numerator, I'm going to get 3x multiplied by x, 3x multiplied by -6. Then I'm going to come over here and I'm going to expand this term, remembering that that negative is going to stick with that 4x. So this will be -4x squared, and then again, here's where a very common mistake gets made. -4x multiplied by 3, -12x. Oh, sorry, I should have put an x there. Sorry, that should have been -18x. Okay, so now I'm going to have x plus 3, x minus 6 in the denominator. My numerator is going to become -x squared, and I've got -18x minus 12x. That is going to become -30x. Now, hey, I can factor that numerator. Let's see if that makes a difference here. I can take out a -x, and that's going to get me... Now, notice I'm not breaking up the 30 into 5 and 6 here because this is just a binomial. It's not a trinomial. Okay? If it's just a binomial, then really what I'm doing here is I'm taking out the common factor. This is going to give me x plus 30 over x plus 3, x plus 6. Okay, well, I wasn't able to cancel anything. Oh, that plus 6 looks terrible. Hold on. Plus 6 there. So at no point in time did I lose any kind of an issue in the denominator. So the restrictions I see at the end are the ones that I had the whole time. And those are going to be that, oops, sorry, my mistake, that's x minus 6. Sorry, I tried to fix that and I wrote it wrong. Which means my two restrictions here are that x cannot equal -3, can also not equal +6. All right, let's keep going. Okay, this guy right here. Now they're just starting to get a little bit more difficult. First thing I got to do is I got to factor. So this is going to give me, over here, the denominator here can be factored. The numerator can't. There's nothing common between the 6 and the 5. But I can take out a common x out of that denominator. Good, good. Now let's take a look and let's talk about the lowest common multiple of the denominator. Bearing in mind that when I see a binomial down there, I have to consider it a complete unit. Okay, like for example, I can't cancel those x's and think that I'm simplifying because x here is not a factor. X minus 1 is the factor. So my lowest common multiple, when I look at that first term, has got to have the same factors. Well, x minus 1, that whole thing becomes a factor. That's it. Over here, I've got an x, so my least common multiple's got to have an x in it. This has also got an x minus 1 in it, but I already had one, which is great. So that's it. That's my least common multiple. So down here, what I got to do is I got to make this x times x minus 1, and then this will be minus x times x minus 1. I am missing the factor of x right here in this first term, so I'm going to introduce that numerator denominator. So that's going to get me x squared and minus, and then I did nothing over here. My next step is simply going to be to put those two together over top of that common denominator. So I'm going to get x squared, and now remember that negative has to distribute to both terms, so minus 6x plus 5. Okay, now I'm in an interesting situation here. Can I factor that? Okay, I've got binomial factors down here. If you factor a trinomial, you get binomial factors. I might be able to simplify this. So again, I leave that denominator the way it is, because I might need to cancel something here. My numerator will be x something, x something. Now, factors of 5 are definitely going to be 5 and 1. This is positive, which means these two are the same sign. This term here is negative. It means these are both negative. And there it is. X minus 1 over x minus 1 becomes my 1. It disappears. And so this finally reduces down to x minus 5 over x. Now, in this case, I have to state x cannot equal positive 1. I lost that denominator here. Okay, that x minus 1 divided by x minus 1, I absolutely need to state x cannot equal 1 because that's no longer obvious from this level of the question here. But up until that step just before it, that restriction existed. I should also state that x cannot equal 0, even though I could see that clearly from the end of that problem. It's awesome. It's good. Another one. Now, this question is only more difficult because it's got another term to it. Okay? First thing we're going to do is we're going to factor. And actually, the only bit of factoring you can do is right here. That's a difference of squares. So 6x over, this will be x minus 1, x plus 1, plus 7 over x minus 1, minus 5x over x plus 1. Now, my least common multiple, and I hope by this point here you've now gotten used to this idea that these binomials become the factors themselves. It's not the pieces of it, it's the whole thing. My lowest common multiple has to have a factor of x minus 1 because it's right there. It's also got to have a factor of x plus 1 because of right there. Then I move on to the next one. This one tells me I've got to have an x minus 1 in there, and I do. Awesome. This one tells me that I have to have an x plus 1 in there, and I do. Excellent. So that's as far as I need to go, which tells me that my first term was fine. I didn't need to do anything to that first term. It already had everything in the denominator that I needed. Over here, though, I had that x minus 1. I have to plug in that x plus 1 there, and then which means I got to plug it into the numerator. Over here, what I'm missing here is the x minus 1. So x minus 1, x plus 1, and then I got to multiply this, the numerator, by x minus 1. Now bear in mind this is exactly the same as this one right here because I've only multiplied by 1, I've only multiplied by 1. These are all over, bear in mind the denominators are the same, so they're all over x minus 1, x plus 1. So it's going to be 6, oh, sorry, I should put that in the denominator, x minus 1, x plus 1. So my numerator is going to be 6x plus 7x plus 7 because I have to distribute that through. And now I'm going to distribute the negative 5x through. So negative 5x squared. And then remember to distribute the negative to that negative there so it becomes positive 5x. Well, I'm just barely off. There we go. Okay. This is still over x minus 1, x plus 1. I've got a negative 5x squared. I've got 6x plus 7x is going to be 13x plus 5x is plus 18x plus 7. Okay? Now, when I take a quick look at that, I'm not 100% sure I can factor that. Like, I'd like to. I'd like to think that I could get a plus an x minus 1, x plus 1 out of that to simplify that down. But I'm not sure that I can. So this is what I do. Off to the side here. Now, I might be tempted, and actually at this point I probably should. You might be tempted to factor out that negative there because it always looks better if that first term doesn't have the negative in it. So we get it down to this term right here. Now I'm right off the sheet here. I'm going to just check something. I'm going to come off to this side here. This is me doing a little check. I'll let that stay visible here, or this stay visible. I'm going to check the discriminant on this. Now, that should take you back a ways, but I'm looking for my b squared minus 4ac. So I'm going to take a look at, it's going to be my negative 18 squared minus 4 times my a value is 5, and I'm going to use the form where I factored out the negative, times negative 7. Okay, so I've gone to my calculator and I've plugged that in. Now I'm going to press enter here, and I get 464. Now, at this point here, it's like, okay, great, what does that mean? Well, let's take the square root of that. Because here's the thing. If you think back to the chapter on quadratics that we did quite a while ago, if the discriminant, okay, and that's the part of the quadratic formula that shows up under the radical, if that's a perfect square, then I should have been able to factor that. And it isn't. It isn't. So that tells me that's a dead end. That's as good as I'm going to be able to get that. Awesome. Okay, good. So I don't have to show any more work there. I'm done. I didn't cancel any of the denominators out, so any of the factors in the denominators. So the restrictions that I see here were the ones that were always there. So x can't equal 1, x can't equal negative 1. So there's my final solution there. All right, couple more. Now this one, in some ways, is quite honestly taking a step backwards in terms of difficulty here. But sometimes this is a very subtle problem, and people don't see it here. Remember that this is like x minus 3 over 1. Okay? Like x minus 3 over 1. So when I'm looking for my least common multiple for the denominator, the only term that has a factor that's significant in the denominator is this x plus 6, that first term. And so that's what's going to become my least common multiple for the denominator. So this whole thing is going to be over x plus 6 over x plus 6. Now this is going to be 4. I didn't need to change anything there. But here, this had an x minus 3. I simply have to multiply that by that x plus 6. So I multiply numerator and denominator by x plus 6. So this is all going to be over that x plus 6. I have 4x plus 6ths plus x minus 3 times x plus 6, x plus 6ths. Now let's distribute this out. So this is going to become x squared. What do we got there? Plus 6x minus 3x is going to be plus 3x minus 18. Let's group together like terms. So x squared minus 3x. 4 minus 18 is going to be negative 14 over x plus 6. Okay. And here we are again. We're staring at another trinomial in the numerator. Am I going to be able to factor that so I could cancel out an x plus 6? Well, I mean, there are a few things we could do here to check to see if this works here, but I'm going to go back to that discriminant again because that's a tool that I know will always work. Now, I mean, I could tell you right now where this is going here, but I want you to see this again and again so that you get comfortable with this. B squared minus 4ac. Let's take a quick look at this. If that turns out to be something if that turns out to be a perfect square, I could factor that. So I'm going to make that, in this case, that's going to be negative 3 squared minus 4 times, and then what was my a? My a was 1, and my c was negative 14, I think. Yeah, negative 14. And I get 65. 65 isn't a perfect square. 64 is. So that means that right there is as good as that's going to get. Let's state our non-permissible. And because I didn't have to cancel any denominators, the restriction I see at the end is the restriction in this problem. X can't equal negative 6. All right, one more. Okay, now I want to do the factoring first, but actually everything's been factored. My least common multiple, when I look at the denominators here, I see a factor of a plus 3 from the first term, so my denominator has to have an a plus 3 in it. I see an a minus 6 in the second term, so my denominator has to have an a minus 6 in it. So here, this will be a plus 3, a minus 6, minus, and this will be a plus 3, a minus 6. So in this case, this will be 3a plus 2, a minus 6. And here, this will be a plus 3 times 4a plus 5. And remember, you can do the multiplication kind of whatever order you want there. I'm just trying to do it to be consistent with what I have in the denominator. So this will be a plus 3, a minus 6. And then I'm just going to expand out the numerator. Now I'm going to put this in parentheses first. The negative in between these two expressions is a little bit problematic, or at least it can be for some people. So what I'm going to do is I'm going to do the multiplication here very clearly before I do the subtraction. So this will become 3a squared minus 18 plus 2. It's going to be minus 16a minus 12. This is going to become 4a squared plus 5a plus 12a is going to be plus 17a plus 15. So, okay, notice I've done the multiplication. Now I'm going to do the subtraction, okay? And I'm separating those out because it's very, very easy to make a mistake with signs. So this will become 3a squared minus 16a minus 12. And the mistake usually is that people don't distribute the negative all the way through. They usually go to the first term and then that's it. So distribute the negative all the way through. And now we group together like terms. Again, my denominator has not changed. And so what have I got? I got 3a squared minus 4a squared, so negative a squared, minus 16 minus 17 minus 33a, negative 12 minus 15, so negative 27. Okay. I'm lazy right now, so I'm going to take the negative out of the numerator. A plus 3, a minus 6. And as I've done a couple of times already, I'm going to check that discriminant. B squared minus 4ac. Okay? So in this case, b was 33. So 33 squared minus 4 times a times c. Oops, sorry about that. So anyway, 33 squared minus 4 times 1 times 27, 981. Now let's just check. Take a look here. Whoops. Don't know what I just did there. Quit. Oh my gosh. Why is that working? Okay, so we're going to take the square root of that answer, and it doesn't work out to be a nice number, meaning that that right there is about as good as that's going to get. So let's state the non-permissibles. A cannot equal negative 3 or positive 6. That's as good as we're going to get it.